Assalamualaikum and good day. Process control is an important system that must be implemented in all industry. Control variables and manipulated variables are one of control system to keep control objective at a desired value and adjust manipulated variable for its purpose. Early 1939 and 1945, cumene is used to increase octane in gasoline. Currently, it is used to manufacture acetone and phenol. Cumene, also known as isopropyl, is produced by reacting benzene and propylene over an acid catalyst such as phosphoric acid or anhydrous aluminum chloride or zeolite. This process also produces byproduct which is diisopropyl benzene. To know the detailed process, we will be with NATASAH at the industry.
Thank you to my co-worker, Ms. Aisyah, who is in the newsroom right now. Now, I'm in one of the cumene manufacturing plant. With me is one of the process engineer, Mr. HAIRUL ZAKWAN. Can I know how this cumene is produced in this factory?
Okay, in the industrial sector, cumene is produced by alkylating benzene with propylene by using an acid catalyst such as solid phosphoric acid. The composition for propylene stream is 95% of propylene and 5% of propane. However, cumene can further alkylate with propylene to form a diisopropyl benzene, which is we call it as DIPB. For the conventional cumene manufacture process, a gas phase packed reactor is operated in the excess benzene to suppress the DIPB generation. Okay, this is followed by 3 columns of the light out first separation train. Okay, the process starts with the total benzene, which consists of fresh plus recycled benzene, is mixed with fresh propylene and vaporized in the vaporizer. Then the vapor is preheated in the feed effluent heat exchanger, or we call it as FAHE, that recovers heat from the reactor effluent. After that, the vapor is heated to the reaction temperature in the furnace. In a reactor, benzene will react with propylene to produce a cumene. Unfortunately, some of the cumene will react with propylene to form a DIPB as a side product. This highly exothermic reaction occurs in a cool cell and tube heat exchanger with catalyst loaded tube. Note that near complete propylene conversion occurs in the PBR. Okay, the hot reactor effluent lost its heat in the FAHE and then partially condensed in the cooler before it is fed into the separation train. There are 3 columns in the separation train. Okay, in the first column, the incondensable inert propane and unreacted propylene is purged as a vapor distillate. For the second column, the benzene is recovered and recycled back into the system. Okay, for the last column, pure cumene is distilled as a product, while the DIPB and some cumene leak down to the bottom. Okay, the DIPB obtained from the third product is sent to the adiabatic transalkylator to react with recycled benzene to form the cumene. Okay, hence we assume that there is no production or zero production of the DIPB in the system. Okay, we can summarize that the cumene production consists of 5 sections, which is the reactor section, propylene reduction section, recycled benzene section, cumene production section, and DIPB section. Okay, our company policy is to eliminate the production of the side products and increase the purity of the cumene.
Thank you for the information given, Mr. ZAKWAN. Next, I handed it over to my friend Aidil, who was in the field with me right now.
Okay, thank you, Tasa. Now I'm with Ms. Loy, the senior engineer for this company. So I want to ask, what is the improvement that can be done in cumene production?
So the improvement I would like to propose is to implement cascade control system at the heat exchanger, where both the main and side reactions takes place. The products are cumene and diisopropyl benzene respectively. Basically, a cascade control consists of 2 feedback control loops, one outer and another inner, 2 controllers and 2 variables where the output of the first controller will act as the set point of the second controller. In the current practice, the heat exchangers is managed by our operator using feedback control system and also manually by using a hand switch. In order to further enhance the control of operating temperature and pressure, cascade control is proposed to replace the existing control system. Cascade control system is one of the most effective approaches as compared to the traditional single loop control. It can significantly improve the performance of control strategies by lowering the maximum deviation and the integral error for disturbance response. Such system is able to provide quicker correction before the system upsets, as the inner feedback loop reacts faster to the disturbances and is closer to the disturbances source compared to the outer feedback loop. In this context, the disturbances refer to the boiler feed water flow, variation in temperature, and also steam pressure. So in this case, by implementing cascade control, the output of the first controller, that is the temperature controller, will be the set point of the second controller, the flow controller. To have a clearer picture on how the system works, let's have a look on this picture. The heat exchanger is first to be considered to be operate in steady condition, where the temperature is equal to the set point and temperature controller output is assumed to be constant. The steam flow rate will ramp up in response to a rapid increase in steam pressure, affecting the control variable. The cascade control approach allows the feedback control loop flow controller to adjust the valve position instantly to bring the flow back to steady state conditions. So I think that's all from me.
Okay, thank you, Ms. Lloyd. Now we go to the next improvement. Okay, now I'm with Ms. Fariehah, assistant engineer for this company. I want to ask, what is the other improvement that can be implemented in this Cumene production?
Okay, first and foremost, before we implemented another alternative of improvement about this Cumene production, we need to identify the problem that occur in this Cumene process. We identified that the problem occurred at the initial process of Cumene production, which is located at the vaporizer. As we know, the flow rate of the input, which is the total benzene and the propylene, into the vaporizer is regulated by the flow controller. However, at the vaporizer, the temperature is high. Thus, when the input is entering the vaporizer, the temperature of the input is increased, but the flow rate is decreases. Thus, this will affect the time that took to vaporize the input into the vapor phase. Thus, the level of the liquid at the vaporizer will be maximum. Thus, will maybe cause the overflow of leakage of the vaporizer. As we know, the input, which is benzene and propylene, is hazardous. Thus, it can cause bad effect to the employer that work there. First, for the alternative of the implementation for this Cumene process, we decided to propose by adding the level controller at the vaporizer. This level controller, which also equipped by level sensor, will sensor the liquid level at the vaporizer. When the liquid level at the vaporizer is higher, the level sensor will identify it and deliver it to level controller. Thus, level controller will respond it truly by lower the level of the liquid at the vaporizer and decrease the flow rate entering the vaporizer. Thus, this system can also be called as the feedback control or closed loop system, which the error is preventing before it could occur. That's all.
Okay, thank you, Ms. Fariehah. Okay, now I will another assistant engineer, Ms. Lina. Now I want to ask, what is the other improvement that can be implemented in this Cumene production?
Okay, before I proceed with the improvement, I would like to explain on the primary function of the distillation column, which is the separation of a feed streams into a top product stream and one bottom product stream. So the basic principle of the separation unit stream is based on the differences in the condition required to change the phase of components of the mixture. So the heating source may be the output streams of the other column, as the vapor raised in the boiler is being produced in The liquid is then removed from the boiler, is known as the bottom products or simply bottom. Okay. So as the vapor moves up the column and as it exits the top of the unit, it is cooled by a condenser. So the condensed liquid is stored in a holding vessel known as the flux drum. Okay, some of this liquid is recycled back to the top of the column, and this is called the reflux. The condensed liquid that is removed from the system is known as the distillate or top product. So for the specific NID, an overheating or low heating from the steam in the reflux will occur as there is no control system that control an exact amount of steam that will ensure a constant amount of a certain temperature at the reflux. So to control the benzene impurity, the benzene leakage down the recycle column must be regulated tightly, as all the benzene leaks necessarily ends up in the product streams. So this may be achieved by maintaining a sensitive recycle column stripping rate temperature by adjusting it to a certain set point with the feed product, which is the second output. So one of the improvements in the control system that may be added to the plant for the Cumene production is the inclusion of temperature control tools, the distillation column and the reflux drum. So as the result, temperature controller on L2, the distillation process of feed from C1 can be done smoothly without the deviation in composition of the residue, as the distillation column run at optimum temperature as per regulated. Therefore, there will be none undesired component at the end of product. Hence, the feed for Syukri will be at desired specification, and the end product purity can be made possible. Okay, so next, as the second improvement, in which the output of production must be at optimum flow, as it will affect the efficiency of the product output. The suggestion to implement a ratio controller as a feedback control system at the output of the reflux drum will be essential, as the ratio control system's goal is to keep the ratio of the variables at a specific value. So, although we may fix the total recycle and fresh benzene to the reactor by manipulating the fresh benzene, the feed temperature of C6's optimum value changes significantly. Thus, the set point updates will be necessary, which eventually can fix the total benzene to propylene ratio. However, if the Syukri feed composition changes, which is a principal disturbance to the process, the ratio would again have to be adjusted. Therefore, a simple alternative is to directly fix the recycled benzene in ratio with the recycled column reflux at L2. This is because if the Syukri feed propylene fraction increases, the feed to the recycled column will be heavier, as it contains more richer products than TS at column 2 products. So the improvement will be maintain the ratio of L2 for ensuring near optimal excess benzene feed to the reactor. In addition, for Cumene production distillation, keeping a specified reflux ratio for a distillation column is important to get the required quality and purity of end product. Thank you.
Okay, thank you, Ms. Ina. Now I pass it back to Aisyah.
Thank you, Tasah and Aidil. I, Aisyah Sabrina. That's it from the news. Thank you and have a good day.